to a net zero carbon emissions throughout our procedures. How we do this is the construction material, we try to replace it with our own innovative and sustainable material. Since our material, it comes out from the plastic, so in our production phase, we don't produce any carbon emissions. And on top of that, usually people, when they try to get rid of the plastic, they try to get rid out of it in an unhealthy way, which is burning the plastic. In our solution, we give another life for the plastic by providing it through a building material that can be used for successful projects like providing safe shelters, F&B units, you can name it. We have built schools in Egypt and we have built schools in Indonesia, and this is all made out of the recycled plastic.
You make it sound very easy, so
I
hope you talk more about the technology and showcase at the Nordic Tech Hub, and maybe leave some teasers for the audience here to go tomorrow to the event and learn more about the technology, inshallah. So, but I'm sure that is much more complicated than that, which takes me to the concept of complexity. And moving to you, Alex and Flotion, when we talk about complexity, so sustainable development challenges are very complex and intertwined, as we say. So they don't happen in silo, and especially in coastal regions and in the very delicate marine ecosystem, there is always integrated issues happening at the same time. So how at Flotion you are avoiding the trade-offs between the costs and the climate and the ocean health? So tell us more about that.
Sure, yeah. So at Flotion we have a nature-based solution. So the oceans are amazing. I don't know how many know this, but we all started in the ocean, 3 billion years ago. I think we wandered up to land 300 million years ago, so quite recently, relatively speaking. So the ocean is a wonderful place. When you go and you have desalination, which is a wonderful solution for water scarcity, invented in the 60s, but it's very complicated to permit. It has environmental harm and it's quite costly and energy intensive. So what we are using is we are actually using the ocean, but we are going deep. Basing this on subsea technology developed in the last 5 decades, we are harvesting fresh water in the deep sea using the natural pressure, which is at 400 to 500 meters near shore. And there you have another thing, which you don't have light, and light creates photosynthetic bacteria that create bacteria, algae blooms and so on, and you don't have that either in the deep ocean. So we're just harvesting water from that deep ocean, and then you get basically two things at the same time. You get better economics because we reduce energy by about 50% because we have the pressure at depth, and you get a more sustainable solution because we don't need to use any chemicals. And we cut down the size of the plant and virtually remove the majority of the pre-treatment, which is more than 50% of a desal plant. So you get all these wonderful things when you're using a nature-based solution, and that's really helping us because traditional infrastructure is already complicated. We are looking at long-term concessionary contracts, and if you're looking at solar or other things like that, you're sometimes competing with biodiversity when you're building infrastructure. We are not competing with biodiversity. We are helping the ocean biodiversity, and we are reducing emissions, and we're solving water scarcity. So solving several problems in one, we call it a Kinder egg. That is a great way to manage the trade-offs. It's a long answer.
Yeah, but desalination solutions usually struggle to make a business case for it, right? And the cost is very high. So how do you bring that into the mix? So not only sustaining the climate health, but also sustaining a good business case.
Yeah, so for desal, the cost metric we're really aiming for is the levelized cost of water, so the cost per cubic meter that you're producing. And that's a combination of the investment, the CapEx,